Okay, let's do a video on additions in different number bases. The first we're going to be using is binary. Binary uses a base of 2. Okay, so we'll only be using noughts and zeros. For an example, we'll use 101 plus 1111. Just as an example, random example out of my head. Okay. With binary, 1 plus 1 will, instead of being 2, as in decimal, we'll go to 10. And you can add these just exactly the same as you'd add normally, but instead it'd be 10, and you carry the 1 and have the 0. Then the same again, 1 add 1 will be 10. 1 add 1 add 1 in binary will not be 3, it will be 1 1, because it goes from 1 to 1 0 to 1 1, then it will go to 1 0 0, and it ends up being very long. So we have 1 1. 1 add 1 again, 1 0. 1 0 1 0 0 would be your binary number if you add these two. Octal, an addition in octal. Remember, octal has a base of 8, which means it uses the digits from 0 to 7. Okay, so for an example, we'll use 7 1 5 and 6 2 2. Okay, 5 and 2 is 7. 7 is fine because it's still in octal, so we can put 7. 1 and 2 is fine, so we can have 3. 7 and 6, however, will equal 13. 13 is not in octal. The easiest way to convert from decimal to octal is just to minus the 2 when you're just doing the basic ones. Obviously further on it goes even more extreme, but for the sake of this, 7 plus 6 would normally equal 13. However, in octal it will become 11. Okay, and then 1 is just 1. 1 0 1 37 in octal. So that's that. Then hexadecimal. Remember, this is from 0 all the way up to 16, number base 16. So instead, A equals 10, B equals 11, etc. So as an example, we'll use A F 1 and 2 3 3. Okay. 1 plus 3 is 4. F, remember F is equal to 15. So F plus 3 is 18. So 18. So 10 in hexadecimal will equal 16 in decimal. Right. So 18 is actually going to be, 18 in hexadecimal is actually going to be 12 in decimal. Okay. So we can carry 1 2. A, which is 10. So A equals 10. Plus 2, that's 12. Plus 1 is 3. So we go along. A equals 10, B equals 11, C equals 12, and D is therefore going to equal 13. D to 4 would be the addition in hexadecimal. So now, if we want to convert it back, we can go find my calculator somewhere. Okay, so to change it back, we must go 4 times the number base, which is 16, to the 0, then add it to 2 times the number base, which is 16, it's the 1, plus d is 13 times the number base to the 2, and that's as far as it goes. Put this into my calculator, and now I'm back. It is equal to 3364. Okay. To work this out, now we must go to AF1. This is just to check everything. To check everything is right, we've got to convert AF1 and then 233, both to decimal. So AF1 would be 1 times 16 0 plus 15 times 16 plus 10 times 16 squared. Put that into my calculator. That is equal to 2801. Right. So we'll go on to the next page. 233. 233 would be, in hexadecimal, 3 times 16 to the 0 plus 3 times 16 plus 2 times 16 squared. Put that into my calculator, and that is equal to 563. Right, so now the only thing we need to do is we take the values that we had earlier. So the values we had earlier was 2801. We add it to the new one that we've got, 563, and then hopefully it should equal 3364. 2801 plus 563 equals 3364. So that's verified that we've done it correctly. And that's the end of the video. Thank you very much.